Hi, today we get to do something fun. This is an unboxing video. So right here we have a brand new piece of equipment for the workshop. It's an Amscope model SM4T bench microscope. So let's go ahead and open it up. We'll probably have to put some of it together, but let's go ahead and see what it's like. So I've got my zebra knife. Now we've got a packing list. So it comes from United Scope. It's an SM4YZ-144A. It's a 3.5 times to 90 times trinocular stereo microscope with a 4-zone 144 LED light ring. And this is a pretty complete set here that I ordered. We get to have this because we're going to start fixing NM series intercoms, and NM series intercoms have a lot of small surface mounted components and you need a microscope to see them. So we've got a box here. Looks like we've got the light ring controller and a cable. These are the two Barlow lenses. We'll talk about that. There's a bunch of styrofoam. This is very heavy and kind of wedged in here. See if we can get it out without destroying everything, making a big mess. Seems to be packaged pretty well. I think this is the microscope itself. And I have a feeling that this, which is really the heaviest thing in the box, is probably the stand. So let's see if we can get this out. Oh, yep. This weighs, I don't know, it doesn't say. Weighs a lot. The UPS guy was happy that he didn't have to carry this up the stairs this morning. I was getting ready to leave to come here from the office, and I saw him pull up, so I waited a few minutes, and I told him, let me help you out. I'll just take this with me and put it in the van, and you don't have to carry it upstairs. That made him happy. Wow. Seems to be taped closed. Hopefully we don't have to send it back, because I don't think the box will make the trip. Ah, there we go. All kinds of good stuff. So looks like it's the stands and the arm. The base is the heavy bit. Got the base, a holder for the microscope, I think. I hope it's got instructions. They even give you a little Allen wrench. More parts of the stand. Ah, this is heavy too. So this is I think it's called a dual beam support, which we'll talk about once we get it put together. I do kind of like throwing stuff around. Nothing left in that. So let's go ahead and see if we can find some instructions. I think the microscope's in this box, and inside here are the instructions. So let's go ahead and get this set up here. So I've got everything unboxed and unwrapped. The instructions are pretty much useless. There is no step-by-step assembly guide. There's some drawings and things, but they aren't exactly the same model that I ordered. There is a picture diagram which kind of gives you some clues. So I guess if you're good at putting together IKEA furniture or something like that, you probably can handle it. If not, I don't know what to tell you exactly. Fortunately, I spent a lot of time building model cars and ships and airplanes when I was a kid growing up. And when you do that, you actually get pretty good at looking at drawings and figuring out how things are supposed to go. So I'm not going to worry about it too much because I have a feeling I'll be able to handle it. So this is the base, this is the heavy part, makes it really stable. And then, I don't know, this is a vertical post. It doesn't really have a, there's a name for it. No idea. Anyway, so we'll call it the vertical post. So that goes there. And then this apparently goes on here like this. And you can tighten that down for right now. And it looks like this, no, yes, no, maybe, not sure. Something goes on here, right? You can't see that very well, hold on. Okay, so then this piece goes on here somehow or another. That piece goes on there. Yep. And this little sleeve goes in this side. And this little sleeve goes in this side. There's a set screw that makes it line up properly, it looks like. Something like that. And then there's the locking handle, which will just do that to hold it in place. And we'll raise this up. This is all quite heavy. And then you've got this, and it looks like this, which is the part the microscope fits onto, goes here. Perhaps like this. Do that. And there should be, oh, this handle goes in here. So there's our basic setup. It's really heavy. Wait, let me raise up the camera. And now you can see it. So the stand is an important part of the microscope because if you, so you can lock this and you can raise this up also to keep it, give it more support. The dual beam design, there's other types of stands that were available, but this kind with the dual beam, one, it's going to slide really well. It feels like there's ball bearings in this part, which means it slides nicely. And also, when you lock it, it's not going to sag or vibrate around, I don't think. And that's important because if you think about it, if you're looking at something through the microscope, you're magnifying what you're looking at. So let's say on an average, the microscope has the range of from 3.5 times up to 90 times zoom. If there's any kind of vibration, can you imagine if there's this much vibration and you're just looking at it, it's no big deal. But if it's this much vibration and it's 90 times that, it's going to be like bouncing all over the place and you're not going to be able to see what you're looking at. So having it be sturdy is important, and that's why the base, I think, is so heavy. So let's go ahead and get the microscope part out and get that on here and see what we got. So unlike the other box, this stuff is all very lightweight. I think these are probably lenses. There's a dust cover which came with it. This is sort of an all-in-one, everything came with it model, which I thought was probably the way to go. Here's the actual, get rid of that. Here's the actual, I don't know what you call it, microscope head or something. And see if we can figure out how to put this together. Ooh, check it out. 2 lenses because it's stereo. All right, so this must go in here. It's pretty easy. And there's a cap here with a port. Here's the port that I think threads in somehow. No, or it I think it snaps in or something. Maybe that's what the Allen wrench is for. Or maybe you need a small. Looks like it's for an Allen wrench. That one seems too big. There's a little set screw in there. There we go. So this is where you can mount a video camera. So you can feed the image to the computer, and if I get a video capture set up, then I can show you what I'm looking at. So you've got caps for the eyepieces, which I think is what are in here. No, that's a lens. And that's another lens. So maybe in these, that's a lens. These are all lenses. They're supposed to be, that says 10x. They're supposed to be rubber eyepieces, which I don't see. Let me go look in the box. Be right back. Alright, mystery solved. So these two that were in the boxes, these are the eyepiece lenses, and if you pull up on the rubber surround thing, they're supposed to pop up into like rubber eyepieces. There's one that's extended and there's one that's not, and these just simply drop into there. Like that. That's pretty good. And these other lenses, this one, and this one, I'm going to leave them in the plastic bags for now. These are called Barlow lenses. This one is 0.5 times, and this one is 2 times, 2x. And these, if you put these on the bottom down here, they allow you to raise up the height of the microscope from what you're working on, so you have a greater working distance, which makes it a lot easier. So that's pretty much it. I think it's pretty set up at this point. I'll have to play around with it. I've never actually had a lab microscope before, so it'll be interesting to learn how to use it. And the point of this is it allows us to work on really, really small stuff. So let me get something to show you. So here's a board. This is the main board out of an NM100 or NM200, and you can see it has a lot of really small surface mount components. This right here, right where the screwdriver tip is pointing, that's an incredibly small resistor, and that's about, oh, it's probably 1/4 of the size of a grain of rice. And even this IC right here, this is an op amp, I think. This is a 1, 2, 3, 4, 5, 6, 7, 14 pin package. Don't know the package numbers by memory yet, but we'll get that nailed down pretty soon. And to remove this and to solder on a new one, you have to really be able to see what you're doing, because the legs on the side of it are incredibly small, and I think even the youngest of us with good eyesight would have a hard time dealing with this, especially these little resistors down here. So that's entirely what this is about. This is about us being able to see what we're working on when we're working on your boards. Oh wait, we've got one more thing to do. We've got to put the light ring on, which is right here. So let's go ahead and see if we can tilt this up. And so this has 144 LEDs in it. They're divided up into 4 quadrants. So good illumination will be important. It's got these set screws here. And I think that it just I think it would have been good if there had been at least some basic instructions. Let's see what we can figure out here. But like I said, I'm pretty good with pictures and all of that. So does this go in here? I think this goes in here. Don't want to strip the threads on a plastic piece here. Alright, and then this, there's a groove in this, and that's where these set screws hold it in place. So that's pretty good. And then we'll have to figure out the best way to deal with the cable so the cable's not in the way. And what else do we have here? We have a controller. It's an adapter for LED lamps. And it looks like we've got on-off and switches for different modes and brighter and dimmer. Plug this in. And we'll plug this in. And plug this in. This is a little micro USB cable. And if we turn it on, we got light. And if we increase it, it looks like maximum. We can lower it down. It goes down in steps till it's off. There. Down in steps till it's off. And then up, brighter and brighter to maximum. And then we have mode. So the left, oh, you can turn off each quadrant. So there's the quadrant nearest me, and then first one to the right, the back one, and the right one, the left one, And I suppose you can turn those off and then lower just the one that's on. So it gives you a nice amount of lighting control. That should help a whole lot. Good light, I think, is important on something like this. So even though you can't see, I'm going to put something under it and see what I can see. Hold on. Okay, so what we've got here, the way this seems to work is, this is these knobs on the side, they're the same one, right and left. These are your zoom knobs, so you can zoom in for a larger image or zoom out for more area on the board. These big knobs back here, these are your primary focus knobs, and then you can also turn the eyepieces to match them up so it's really sharp, and what you're seeing is a stereo image. It's sort of like it's two images when they're out of focus, and as you adjust it, it comes together and becomes one, which is pretty good. And I can look in here, and I think the nice thing about it is you don't need glasses. So I'm looking at an LM339, and it's about, on the board, it's probably about 3/16 of an inch by 3/8 of an inch. And I'm looking at it here, and although it's hard to tell you exactly, I would say on an average, to me, it looks like it's about 3/4 of an inch wide, and it's about 2 inches long. And you can clearly see the legs that come out of each side of the chip, and then they have the little feet, and they sit on the pads, and the pads actually look pretty enormous. And you can also read designation numbers on the other components very easily. I could never read them by hand, even with my other magnifying headpiece that I wear a lot. The markings on them are just too small. So I'm going to go ahead and put one of the Barlow lenses on and see how that raises up to give me more working distance, because this is pretty shallow right here. From the light to the board, it's probably less than 3 inches, which is kind of tight. So let's see how it works with a Barlow lens on it. Alright, so I tried the 2x Barlow lens, and I couldn't seem to get it to focus. All I had was a lot of blurriness, so I'll have to read up on that a little bit. So then I tried the 0.5 times lens, and now I have a nice clear, really huge image of our LM339. It's just about the same size visually as it was before, except now instead of like maybe 3 inches, I've got a good solid probably almost 7 inches between the bottom of the lens and the circuit board itself, which gives you a lot more room to get in there with a soldering iron and work on it and do that kind of stuff. So let's see. I'm going to take my smallest soldering iron tip, and this is actually too big for working on surface mount stuff, but it's the smallest one I have here for right now. And if we go in here, wow, it's like ginormous compared to the leg on the IC. And this is a, let's see what size this is. I think this is a conical tip. I guess there's no measurement on it, but I think it's a 2 millimeter tip, and it's hard to relate to you how small it really is. The very end of it, it's round, it's conical shaped. It's about the same size as the end of a ballpoint pen. So if you can sort of get that in there in your mind. And when you put it under the microscope, let's say I was going to solder the legs on this little IC right here. When you put it here, it is easily, if I line it up, whoops, if I go straight, the tip, the very tip, which would be like the very end of the ballpoint pen, the tip is probably 3 times wider than the leg on the IC. which is much too wide. We need a much smaller tip, so we'll have something coming for that pretty soon. But all in all, I think this is going to work really well. One of the things I wanted to see, oops, we have some transistors right down here. There are 2 transistors, and the markings on them are so incredibly small, and also it's dirty that it could not see it before. But now, if I turn it this way, I can clearly read. I zoom in just a little. It says S1P3, which doesn't tell me anything, but that's where the internet comes in handy, because you can simply look it up and you'll be amazed at how all of these markings are all over the internet, and you can usually figure out what it is if you don't have a schematic, but we're working on a solution for that. If I zoom over to this other chip over here, it's upside down. I can easily see that it's a 4580 from JRC. JRC is a Japan Radio Corporation. They're a manufacturer of components. I can read the values on the resistors. We've got a 2672, another 2672, and a 348, and so on. We've got a 560. Back to our LM339. There's actually three of them on here. And we can actually check out the microcontroller. There it is. And you can clearly see, if I get my big finger out of the way, wow. So I'm looking at the microcontroller. Microcontroller in real life is about the size of a standard postage stamp. It's maybe 5/8 of an inch square. And in the viewfinder, I would say on an average it looks like it's about 4 inches square. And it's easy to see. It's a Texas Instruments. It's a M430 F4370 revision H. And again, the thing about this is, the reason a microscope like this is necessary is this is an 80-pin package. So there are 4 sides. There are 20, I think 20 pins per side. Could actually be more than that. I guess I could actually count them now if I wanted to. But if I go in here with the soldering iron, the smallest tip I have, the tip, the best you could do if you use this tip is to do 2 pins at a time. You can't touch up just a single pin because the tip is just way too big, and even 2 at a time is kind of a stretch because it's still hanging over the edge right near the next one on both the left and the right. So this will be a valuable tool when it comes to working on this really small surface mount stuff. One of the reasons that I decided to go with, this is an optical stereo microscope as opposed to a USB microscope, which is basically a high resolution camera, and you see it on the screen. Trying to solder here while you're looking at the computer screen, that doesn't work very well. It's much easier to learn and have the dexterity of your hand under the screen, because you're seeing it live as it happens. If I move the soldering iron tip, if I put it in the field here, if I move it to the right, it moves to the right. If I move it to the left, it moves to the left. It's not opposite or upside down or any of that. And this tip right here, so this is a big tip. This is about, this is probably 3/16 of an inch wide. And if you get in here with this, if you were going to try to drag solder on the IC, you're covering, looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pins at a time. And while that might be speedy, that's not the way to do it. So, this is the new toy for the shop. It's my Amscope microscope, and you'll be seeing this in more videos. And if it works out and if it seems like it's a necessary thing to do, we'll probably get the video camera that hooks onto the top here and learn how to do some kind of screen capture thing so you can see what I'm working on, because people seem to find that interesting. So I don't know, we're making up some of that kind of stuff as we go, but for today this is the first new piece of lab equipment to work on NM series NuTone intercoms. That's all. Hope you found it interesting. I did. I thought it was fun. I'm looking forward to playing around with this some, learning more about it, and sort of becoming proficient at operating it. If you like it, give the video a thumbs up, because that always helps. If you like our videos and like our channel, please subscribe. There'll be a banner right here. Go to our YouTube homepage, click on the bell or on the wheel, put in your email address, and every time we post a new video, you'll get a notification and you can watch it. That's all. I'm going to look at some really small stuff now. See ya.